For the next two lessons, we're going to be discussing the sun and its energy, and this lesson will be on fusion and fission. Alright, so we're going to start with some focus questions. Is it possible to make electricity by using the same process that powers the sun? And what process powers the sun? And what forms of energy does that process produce? Alright, a little bit about the sun. So like we've said in previous lessons, our sun is a star. It's also the largest object in our solar system. It is 99% of the solar system's total mass. So everything else in the solar system only makes up roughly 1% of the solar system. The remaining 99% is the sun. The sun is 330,000 times as massive as Earth. It is made of hydrogen and helium and has no solid surface. So when you hear the sun referred to as a ball of burning gas, that's fairly accurate. Scientists cannot directly observe the inside of the sun, but can explain much about it through the use of computer models, also analyzing the electromagnetic energy that comes from it, looking at the sun with special filters that allow you to look at the sun through telescopes without damaging your eyes. So we do have ways to study the sun, even though we'll never be able to go there because we would get melted or burn up before getting close enough, right? Alright, so inside of the sun, it is gaseous due to its high temperature. We're talking like 18 million degrees Fahrenheit. And we're talking, temperatures here that us human beings, we really have no way to fathom. I mean, we know what it's like to, be very cold, maybe near 0 degrees Fahrenheit. We know what it's to be, we know what it's like to be in really hot temperatures, maybe 100 or more than 100 degrees Fahrenheit. But 18 million degrees Fahrenheit, I mean, that's just really hard for us to wrap our heads around. We really can't. It's extremely high temperature. Because of this extremely high temperature, the gases inside of the sun are ionized. Okay, this means they're composed only of atomic nuclei and electrons. And this is this whole other state of matter. We often talk about the three states of matter, but when we say that, we're talking about the three states of matter that exist on Earth: solid, liquid, and gas. But in the sun, there's this other state of matter called plasma. And that's where, like I was saying, all of these gases inside of the sun are ionized, meaning they're only composed of the atomic nuclei and electrons. The process that powers the sun is known as nuclear fusion. All right, let's talk about ways of producing energy, because these are things we're going to need to know throughout the semester from here forward. All right, the first we're going to talk about is combustion. This is a very traditional way of producing energy. You burn a fuel in the presence of oxygen to produce heat and light. Okay, burning wood or coal is combustion when you set those on fire and burn them. Any fossil fuels, coal, natural gas, and any other fuel derived from petroleum like diesel fuel or gasoline, okay, you burn them in the process of combustion. The engines in our cars, you often hear those referred to as combustion engines because that's what they do. They burn a fuel such as gasoline in the presence of oxygen, and it produces heat and the energy that drives the car. All right, now let's talk about fission and fusion. We're going to talk about them together because they're related processes, but they're related in their the fact that they're total opposites of each other. Okay, with fission, heavy atomic nuclei or large atoms are split into smaller, lighter nuclei or atoms. So you have a large atom that is split into smaller atoms. All right, and it produces energy. This is the process we use in nuclear power plants. Okay, now an easy way to remember that fission is splitting atoms is to remember that the word fissure, which is related to fission. All right, a fissure, if you talk about a fissure, if you're talking about geology, you're talking about some kind of large crack or gash in the earth. Okay, if you're talking like in medical terms, a fissure is like a tear of the skin or an organ or something like that. So fission or a fissure, that means like splitting or tearing things apart. Okay. On the other hand, the word fusion, we more readily know what that means. To fuse two things means to join them together. Okay, so with fusion, you're taking smaller atoms and you're combining them into a heavier, larger atom, and it releases energy. Okay, this is the process that the sun uses to produce its energy. Okay, you have hydrogen atoms in the sun, and they fuse together to form helium atoms, and it produces that radiant energy. And this is the same thing that other stars do as well. Okay, so I didn't mention earlier, but fission actually occurs in nature too. It goes on inside the Earth. Okay, there'll be more about that when we get to the geology lessons later on in the semester. But just remember, the main difference between fission and fusion is that with fission, you're splitting atoms to release energy. With fusion, you're joining atoms to release energy. And here's a diagram of fission. You don't have to study this and know it really well. It's just demonstrating. Okay, you've got a larger atom here. It's being split into smaller atoms, and energy is released. Same deal with this fusion diagram. You don't have to study it and know it real well. It's just showing you have these smaller atoms. They combine into a larger atom, and energy is released. Okay, so during fusion, some mass is lost, which to us maybe so far in the science classes you've had so far doesn't seem to make sense, because we're always told matter cannot be created or destroyed, right? Early on in science classes, in our elementary and middle school science classes, you probably heard matter cannot be created or destroyed, okay? Now, after hearing that, this seems to present a problem, because in fusion, when the two hydrogen nuclei combine, or the two hydrogen atoms combine, you end up with helium, okay? Now, the atomic mass of two hydrogen atoms is greater than the atomic mass of that one helium atom. So what that means is when the two hydrogen atoms are combined to form a helium atom, some mass is lost. Okay, so when you realize this, you're like, well, hold on. Matter is not supposed to be able to be created or destroyed. And it's not. What's happened is some of that mass has been converted into pure energy. Okay, and this is described in Albert Einstein's theory of special relativity, which luckily we don't have to go into in depth. We just need to know that that's what explains this loss of mass that occurs during fusion. All right, so what if humans could control fusion, or why do we want to control fusion? We said earlier we can already control fission in nuclear power plants and produce electricity with that, right? So why would we want to do fusion? Well, first of all, fission has some problems. Okay, one of the main problems is that it produces a radioactive waste that has to be stored and monitored for, get this now, 10,000 years. So this waste, we believe it'll be hazardous to us for the next 10,000 years. So do we really want to be producing waste that's going to, continue to exist and maybe be a threat to us for 10,000 years? That's a big problem. Also, with nuclear fission, there's a possibility of meltdown if you have problems with the process of fission, with maintaining the process at the nuclear power plant. You can have a nuclear meltdown. These are very problematic. We had one in recent years. In 2011, the Fukushima reactor in Japan melted down after the earthquake and tsunami that occurred. You've probably heard about Chernobyl in the past, in the former Soviet Union, where they had the meltdown of a reactor, and the area there is still radioactive to this day. They still have problems, and that happened way back in the 80s. So nuclear fission, although most of the time it's performed safely, there's some concerns, there's some problems, and really if we could perform fusion, it would be better, because fusion would be much more efficient in producing energy, and it would be clean and limitless. It's a process. It's like a renewable process we can keep doing, and it's not going to produce all that radioactive waste that has to be stored and monitored for that extremely long period of time. So we would really like to be able to control fusion, and scientists have been working for some time to try to control fusion and use it to produce our energy. So I'll just read the little news blurb here. Okay, this is kind of old. This is from at least 7 years ago, but I'll just go ahead and read it. It says, in Beijing, scientists on Thursday carried out China's first successful test of an experimental fusion reactor powered by the process that fuels the sun, a research institute spokeswoman said. Okay, so some advances have been made in this, but still at this point, we're not able to really control a fusion reaction the way we'd want to. The fusion reactions happen under such extreme conditions that it's really hard to maintain them and control them and contain them. Okay, you got to think about this. This is a process that occurs inside the sun, and we're talking about 18 million degrees Fahrenheit temperatures and things like that. So fusion happens under extreme conditions, and so we're having to try to develop ways to maintain and contain the reactions so we can use them for our energy needs. Okay. China, the United States, other governments are pursuing fusion research in hopes that it could become a clean, potentially limitless energy source. So if we can harness fusion for all our needs, we don't have to burn fossil fuels anymore. And we know that we don't want to burn fossil fuels anymore because A, they're going to run out. They're not going to last forever. And then B, when you burn fossil fuels, it results in carbon dioxide emissions, which contribute to our global warming problem. So we really would love to be able to contain fusion in the future, and that's why we're talking about it right now. All right, so now that we've laid both of these out here and why we want to be able to control fusion, let's go over the differences between fission and fusion one more time before we wrap the lesson. Okay, nuclear fission. All right, so here's some little hints on how to remember. They've got the I here emphasized and the I in splitting emphasized. Okay, nuclear fission is splitting an atom into two new ones and releasing energy. In nuclear fission reactions, also called radioactive decay, a neutron is aimed at the nucleus of a large unstable atom like uranium, thorium, or other radioactive elements. The extra mass of the neutron causes the radioactive nucleus to split apart, forming lighter elements, free neutrons, and great quantities of energy. This process causes convection currents that move Earth's tectonic plates and generate earthquakes and volcanic eruptions. So like I was saying earlier, fission occurs naturally inside the Earth, but we also have found out how to harness it for our energy needs in nuclear power plants. Okay, nuclear fission. Again, it's the source of energy in the core of the Earth that produces heat from the decay of radioactive elements. It produces vast quantities of energy. It does not produce particulate air pollution like fossil fuels and coal. So we're not getting any carbon dioxide emissions or any other harmful pollutants that come from burning fossil fuels. We don't get that from nuclear fission. All right, nuclear fission involves the splitting of harmful radioactive elements. Loss of control of the fission reaction can lead to harmful radiation exposure. Also, fission produces a radioactive waste product that will need to be stored and monitored, and we think it'll be dangerous for the next 10,000 years. So we really don't want to produce that. We would really like to move from fission, which in some ways is advantageous when compared to burning fossil fuels, to fusion, which we believe will be a lot better for us. Okay, here we've got the U in fusion emphasized, all right, along with the U in fusing here. So we're emphasizing that nuclear fusion is the combining or fusing of two atoms together into a new atom in order to release energy. All right, during fusion reactions, nuclei or atoms collide and fuse, eventually forming atoms of heavier elements and producing enormous amounts of energy. Fusion of hydrogen to helium occurs in the sun and is the source for all external weather-related events. Okay, so fusion really, because it occurs in the sun, is the source of all energy on Earth, really. Okay, and we'll be talking about that later on, that the sun is actually the source of all energy on Earth. And we'll be talking about why in future lessons. All right, with nuclear fusion. All right, nuclear fusion is the source of energy in the sun that produces heat from the fusing of elements like hydrogen. Fusion produces unsurpassed quantities of energy. What that means is there's no other process that produces more energy than fusion does. Fusion is highly efficient. Fusion does not produce particulate air pollution like fossil fuels and coal. Okay, again, we want to move away from fossil fuels. I stated earlier the reasons why, but also fusion is just simply much more efficient as well. It's clean. It's a limitless source of energy if we can harness it. And it will meet all of our energy needs if we can harness it. Fusion does not produce a radioactive waste product like fission does. Okay, so that's another advantage of nuclear fusion. Another reason we would like to be able to harness it and use it for our energy. Currently, we lack the technology to maintain reactions as a viable energy source. Okay, and if you remember from back in our ecologic footprint lesson, we don't always know what problems we will or won't be able to solve with technology. So fusion may be something that forever remains out of our grasp. We may never be able to develop technology that will allow us to control these reactions and use them to produce limitless energy. But we would like to, and we are working towards it.